So Module 5 is a review of number systems. Uh, Binary number. So we have different numbering systems. Binary number are number system that consists of ones and zeros. We've discussed the importance of these binary numbers last time during the physical layer. We mentioned that ones and zeros are bit representations, right? It represents the nature of the signal that flows through our cables. So they're binary numbers. Our number system, the number system being processed by humans, we call it as decimal number, consists of numbers from 0 to 9. Okay, example with the IPv4, its nature is in 4 dotted decimal. Like this one, I have an IP address here of 209.165.200.225. So it is in decimal and then uh, separated by a dot. Okay, four decimal numbers. When we talk about the number of bits in binary, there are 32 bits. So since there are four numbers, so each number has 8 bits. This is why each number we call this as an octet. Okay, we define octet as a number that has 8 bits. Okay, there. Some details about IPv4 addressing. We were taught during our elementary days, say if we have a number of 3,567, this 7 is in ones, in exponential notation is 10 raised to 0, and then for 6 is in tens, in the exponential is 10 raised to 1, 5 is in hundreds, 10 raised to 2, and 3 is in thousands, right? Elementary days pa yan. So, say, example, let's say 3, so its positional values again in thousand, so that's 3 times 1,000, which is 3,000, plus 5 times 100, so 500, 6 times 10 plus 6, which is 60, and 7, 10 raised to 0 is 1. Any number raised to 0 is 1. So 7 times 1 is 7. We add this up, we have the given 3,567. This concept is very important in the binary decimal conversion. Same concept as with the binary. Okay, so let's say if I have this given 1, 1, 0, 0, 0, 0, 0, 0. Okay, this should be 1. Okay, this should be 1. And then this should be 0. Okay, uh, there's the given doesn't match here. So again, this is 1 and then this is 0. So the rightmost given, um, its exponential notation is 2 raised to 0, which is 1. And then the next one is 2 raised to 1, which is 2. Again, this is in binary. 2 raised to 2, which is 4. And then 8, 16, 32, 64, 128. Okay? So, for example, this is very important because this is the shortcut to convert a binary to a decimal. So, since this is the positional value of the binary number, so let's say if we have 1, 1, 0, 0, 0, 1, 0, we position the given to the positional value, which is this one. Okay? So, like, we have a 1 in the 128 and a 1 in 64 and then 1 in 2. What we do to get the decimal, again, what we do to get the decimal equivalent of this binary value, we add those positional values that has 1. So there is a 1 in 128, also in 64. So 128 plus 64 is 192. Plus 2 is 194. And there. So this is 194. That is the decimal value of this given binary value. Okay, this should be 1. Okay, there. We will have more practice exercise in the IP addressing workbook. I will give that during our live session for me to know that you really understood the binary decimal conversion. Okay, so again, we'll work on this binary decimal conversion uh, during our live session. So for example, let's say I have um, a given decimal number of say 160. We are to convert this in binary. Okay, again, this is 160. We convert this in binary. When you work on the binary decimal conversion, this is the secret. All you need to do is to have these positional values. Okay, and you can work with binary decimal conversion. So all you need to do is to fill in the 160. So I put 1 here, right? So I already have 128. If I put 1 here, that will be 192. So it should be a value of 0. If I put 1 here, 128 plus 32 is 160, right? So therefore, values here are all zeros. It should reach up until 1. Okay? So, you should always have this positional value. In IP addressing, again, we're discussing this because of the IP addressing. Always have these positional values from 1 up to until you reach 128. So again, binary decimal conversion, we will deal with that a lot during our IPv4 addressing topic, especially on the part of the subnetting. Okay? Very important to again assign an IP address to our end device so as with the interface in our routers. Okay? So there's a need to convert because our network devices and end devices process binary format, while as human we understand decimal. Oh, there's another numbering system, okay, we call as a hexadecimal. Hexadecimal has 16 numbers. It's alphanumeric, okay? So there are specifications we have, especially in computer network, that uses hexadecimal. So in hexadecimal, it consists of 0 to 9 and then A to F, okay? Uh, A is equivalent to 10, okay, in decimal. B is 11, C is 12, D is 13, E is 14, and then F is 15. Okay. One uh one component that uses hexadecimal is IPv6 and another component is the MAC address. They are in a hexadecimal format. Okay. Okay, again IPv6 is in hexadecimal. IPv6 has 128 bits. Okay. And usually consists of four hexa each field no has four hexadecimal numbers and there are 8 fields. We call this as a field. Field field. Okay. So in this field there are 16 bits. Yes, 16 bits. Okay. Four hexadecimal numbers and consists of 16 bits. So since there are 16 bits, we call that number as hextet. Okay, like this one, the FFFF, we call that as hextet. We will discuss this further when we are on the part of the IPv6 address. To summarize, binary is a base 2 numbering system that consists of the numbers 0 and 1 called bits. Decimal is a base 10 numbering system that consists of the numbers 0 through 9. Binary is what hosts, servers, and networking equipment uses to identify each other. Hexadecimal is a base 16 numbering system that consists of the numbers 0 through 9 and the letters A to F. Hexadecimal is used to represent IPv6 addresses and MAC addresses. IPv6 addresses are 128 bits long, and every 4 bits is expressed by a hexadecimal digit for a total of 32 hexadecimal digits. To convert hexadecimal to decimal, you must first convert the hexadecimal to binary and then convert binary to decimal. And to convert decimal to hexadecimal, you must first convert decimal to binary and then binary to hexadecimal. So this ends Module 5. It's just a short module. Keep safe. Together we learn as one.